Hello, good evening, everyone. Please confirm once that you can see me, you can hear me, as well as you can see these slides. Okay. Thank you so much. Let us begin. So, very good evening, everyone. My name is Ambush. I am research scholar at Agriculture and Food Engineering Department from IIT Kharagpur, and I will be taking your live interactive session for the course Data Analytics with Python. And what we'll be doing in this particular session, we'll be solving some of the uh, multiple choice questions based on the previous week's content. Okay. In front of you all, I'll be solving and you shall try first, try to give response. Then we shall discuss. Okay. We shall discuss what are the concepts, how things are dealt. Okay. And after the this particular part of the session is over, I'll be walking you through some live examples, some coding examples to demonstrate some of the concepts based on the questions and the concepts which we have discussed in this particular session. Okay. So let us begin. Okay. The very first question for the present session is this one. State true or false. Okay. State true or false statement is there is no difference between expected x value of y equal to 0 plus 1x and y equal to 0 plus 1x plus e. Both are regression equations. Whether this statement is true or false, try to give your opinion. Okay, then we shall discuss. Try to give your opinions. Try to answer. False. Okay, good. False. Okay. False, false, false. Okay, good. Rest of the people, give your opinions. Try to see. Try to give your opinions. Okay. Okay. Good. All are saying false only. Okay. Yeah. Yes. Indeed, this statement is false only. Okay. Why so? Let us see. First equation which was given to you is this one. Expected value y equal to 0 plus 1x. Okay. It's a deterministic equation in which expected value of y given x is calculated. This equation is of this particular form. Okay. Only in some of the cases you can call it population regression line. Okay. Average outcome of y for a given x. Okay. So no randomness is involved here. Straight linear equation. Okay. No randomness. Nothing is involved here. True underlying relationship will be discovered. Okay. 0 plus 1x. 0 will have no meaning. Expected value of y given x will be equal to x. Okay. So that is your deterministic mean function. Okay. Straightforward. Expected value of y given x equal to x. Okay. This was the first equation. Now the next equation was expected value of y. Okay. Or okay. Expected value is not good. Y equal to 0 plus 1x plus e. This one is your stochastic or real data model trained equation. Okay. It will actually observe the values. Okay. It will actually observe the values of x and incorporate in y, and we will add one particular term which is your e. E is your error term. Okay. E is the error term or the random noise. Okay, which we have incorporated here. It will try to capture your measurement errors, omitted variables, natural randomness. Okay. So even if your x is fixed, y will vary because of this particular e. Okay, e is a particular term or the error term which we have added. Okay, that is the difference between two particular equations. Y is equal to 0 plus 1x plus e, and expected value of y equal to 0 plus 1x. Okay, that is, these are the two given equations. Okay. So difference is, first of all, in the first equation you are calculating the expected value. In the second equation you are just modeling y with respect to x, and you are adding one another term which is the error term. Okay, this difference you have to know. Now you see, if you take expectation both the side of the second equation, okay, expected value of y given x, okay, you can take the expectation both the sides. Okay, that is not an issue. Expected value of y given x, okay, that will be equal to, since y is equal to x plus e, so expectation of x plus e. So expected value of x with respect to x will be x only. Okay, so x will come out. Then we come to expected value of the error. Okay. So in regression, you have to assume that error is constant. If error is constant, expected value of error will be equal to 0. Okay, it is not varying with respect to the variables y and x. It is assumed. Okay, if error in itself is changing, okay, then you go for dynamic error modeling. Dynamic error modeling or noise modeling is very, very important in cases of signal processing. Okay, when you are processing signals which are coming randomly from sensors, in that particular case, you cannot assume that the expected value of error is equal to 0. The very basic of signal processing and noise modeling starts from this particular equation only. This is very, very important for you to understand that when you will treat expected value of error is equal to 0 and when you will treat expected value of error not equal to 0. Okay. I will tell briefly about it in sensor fusion. Okay. There is a particular term sensor fusion. Most of you must be computer science students, but you should know little bit more about sensors, their fusion, and application of AI in embedded systems also. Okay, because nowadays getting knowledge of alone in the field of just computer science won't help. Okay, coding is very very important, but coding into machines is now gaining much importance. Okay. Coding to the machines means your code is not restricted to your Google Colab or your system only, your PC only. Your code will directly run onto the embedded systems or edge computing devices. They will further control some of the actions in the physical hardware. Okay, some of the actions they will be taken in the physical hardware. For example, operating a DC or AC motor. Okay, this is the simplest example. Or glowing an LED bulb, switching it on and off from your embedded system, microcontroller, edge device, all three terms are analogously used. Or even from your laptop, if you are trying to blink an LED, okay, you can do that also. So these all the operations they will be feasible if and only if you will be coding into the machines. Okay, your code will not be restricted to the machines, to your laptop, okay, or your personal computer. What are edge devices? And my research field is on this only, robotics only. So I can here show you. If I point it out to the camera and give you a close view to you, try to see here this particular board you are seeing. I think you can see this particular board. This one is having, see here, pins, various pins it is having. In total, it will be having 32, 38 pins, 16 pins on both the sides. This is an ESP8266 board. Okay. So these type of boards, these are your edge devices or microcontrollers or edge hardware. Okay. Here one USB cable will be connected and through your IDE, that is your integrated development environment or the software, the code will be pushed into this particular board and this particular board will be able to control some of the actions in physical hardware. Okay, it will be able to control the rotation of DC motor, AC motor. It will be able to control relays. Okay, and various other physical hardwares which you must have seen in your electrical engineering lab. Okay, electrical engineering laboratory, you must have seen various components like diode, transistors, capacitors. Okay, and different circuits are there. Okay, so example of circuit also I can show you. This is a typical example of circuit, basic circuit. Okay, this is a DC motor controller. Okay, so likewise you must have seen various components. See in this particular chip, a lot of components are soldered. Like this one is your microprocessor, trying to show you. Okay, this one is your physical microprocessor. The gates which you must have read about in your class 11th and 12th. Okay, and or not XOR. Okay, in class 12, there is there is a chapter about gates and gate, not gate. Okay, and you must have been studying this in computer science well enough. Okay, all the with the help of all these gates, this particular chip which you are seeing here, okay, these three chips, they are identical. Okay, these are known as microprocessor chips. Okay, or microprocessor chips, they execute various types of decision making process. Okay, so using these conditions only. Okay, all the data is stored here, and it is having one, which type of memory? It is having read only memory. Okay, read only memory. When I will push the code from my computer inside this particular chip, okay, it will get stored for a certain period of time. After that, I will be able to erase it and again rewrite it. Okay, it is known as EPROM, erasable programmable read only memory. Erasable programmable read only memory. Okay, this is the physical example. And see here, various thermistor is there. A small orange color thermistor is there, if you can see. Okay, and capacitor is there. And this one is known as reset switch, which can reset the entire board. Okay, and what else I can show you here? There is an LED bulb, resistor, and various other components are there. Okay. See here, behind this particular board, this particular blue colored board which you are seeing, this is known as printed circuit board. Okay, or PCB. And this one is your jumper wire, which is the physical switch. Okay, there is a physical switch also, which if you I disconnect here, the entire board would be disconnected. Okay, behind this, these are the pins through which various wires will be just connected, and you can see here. See, try to see, there are different soldering has been done. Okay, different components have been soldered on this particular blue colored board. Okay, using soldering iron and solder wire. Okay, so this one is known as printed circuit board. Okay, I don't know whether you have seen this in your electrical engineering courses or not. That is why I am telling you somewhat detailed information about this particular things. Okay, these are known as edge computing devices or edge hardware. This is able to in with the help of this particular boards, okay, or microcontrollers, you are physically able to control various devices. You are physically able to code into them. Okay, so nowadays code is not just restricted to GitHub only. You fetch the library from GitHub, then you put inside your edge AI devices, okay, edge devices, and then with the help of artificial intelligence, you embed artificial intelligence in them, okay, and they are known as edge AI devices. And this is the current area of research which incorporates electrical, electronics engineering, and mechatronics engineering, computer science engineering. All the departments have to work together, okay, in order to build robots and various other automation systems. So the era that has that in which the coding was restricted only to personal computers, you run a code and then you check errors and then you push your code to GitHub repository where some another person will use that code, okay, to build some another computer system, embedded system. Okay, that has gone. Nowadays, edge AI devices is the new era in which your simple microcontrollers, okay, like your Arduino Nano, Arduino Uno, okay, starting from this to Raspberry Pis, to Jetson Nano, Jetson Xavier, Jetson Oran Nano, Jetson Xavier Onyx, various variants are there. These are your edge computing devices in which you can physically embed your code. Okay, so your coding potential needs to be up to that much level when you are able to physically execute your code. Whatever logic you have given, you are able to sense. Okay, that process is known as sensor fusion, in which various sensors are fused together. Okay, various sensors are fused together to assimilate some of the information from the sensors. Okay, and based on those particular information, some decision has to be executed. Hmm. So entire this architecture is known as Edge AI architecture. Okay. So this is the research domain in which you should be well aware of that. I see a lot of repositories on LinkedIn in which various researchers like you all, or various undergraduate students, postgrad students, even PhD researchers post their projects, which are regarding computer vision, some are regarding this robots, okay, mechatronics part. So all of that information has to be assimilated so that we are able to automatically control machines. Okay. Machines themselves have to be enabled for decision making process. So various domains I have discussed. These all are the domains in which people generally do specializations. Okay, various PhDs are also done in in these separate domains. Okay. So you must have some basic idea that whatever code nowadays I am writing, suppose I have written this amount of code. Okay, I have imported these libraries. I am going for machine learning, deep learning, regression, as well as in this particular course you are working with Python. So you have to understand that whatever code you are writing, that is not restricted to your machine only. That will go inside various of the embedded systems, and they will there you should be able to perform some of the operations. Before 2020s, okay, coding was restricted to either front-end part, back-end part, and people were building various softwares, various apps, and various other technologies they were trying to build. Okay, so that is fine. That restriction was there. Okay. So that is fine. But nowadays, what the technology is about, it is about coding into machines. So you should gradually try to expand your expertise in which aligns to industries. Okay. So that is why I told you information about these sensor fusion. Because nowadays industry is talking about these particular things. Okay. Coding in itself, any AI agent, RAG agent, agentic AI bot, they are able to handle. Right. Coding into the machines is the research gap which you as a student or as a professional can bridge. Okay, not many people specialize into it. So try to develop your skills in such a form and manner in which you are able to physically show your coding skills into a hardware. Okay. Because whatever logic, whatever mathematics I am applying, and I have learned from various earlier classes, okay, from class 1, 2, 3, 4 onwards, whatever mathematics and whatever skills I have gained, as an engineer, I should be able to logically apply them and create something new, solve some of the problems, solve some of the challenges. Okay. That is what is very important in this era of AI when people are getting laid off like anything. Okay. So my advice to you all will be like this, that you should be able to solve problems. You should be able to represent your ideas. Okay. When you are representing your ideas and you are able to physically generate some of the new hardware and software integrations. If you are able to do so, then whenever you will go to any industry, you will never be replaced from today up to 100 or 200 years also. Because whatever you have learned, you are able to apply, and you are able to apply those concepts, and you are able to solve a physical problem. These three stages, if you are able to do, then you can never be replaced. So, whatever students I am interacting with, this is my sincere advice to you. Okay. So, now I will stop. I deviated much from the topic which I was about to teach in this particular session, because sometimes it is to instigate your research interest. I have to speak and show something. Okay. So this was regarding sensor fusion. I can talk much upon it, but I should not. I should restrict myself to the session. Okay. So coming back to this particular concept, expected value of error is assumed to be zero. And what I was telling you, whenever I am fusing some of the sensors, I am physically sensing something. Okay. Sensing through some hardware, I will never assume that expected value of error is zero. I will assume that error will be increasing, decreasing based on time lapses. Okay. When I will be assuming that then I will be able to form a time series. Okay, one new term is there, that is time series. You will be able to form a time series, means with respect to the time, with respect to time. Okay, I am able to plot the array. Okay, for now only. Okay, you can you can think of time series like a series. Okay, series of variables which has been taken with respect to time. Okay, just for simplification, I am telling you there is a lot of mathematics behind time series, but for the purpose of explaining to you what is time series in short, I told you this. Okay, so you can think of that with respect to the timestamp. We have taking a number of rows, okay, with respect to timestamp. Okay, so for you can assume time series like this. Okay, so whenever you will be given a time series, you have to never assume that the expected value of error will be zero in this particular case. Okay. There will be some expected value of error that will not be zero. Then you will go for modeling of that particular error. Okay, that is known as noise modeling. Okay. When you try to model the noise, and there are various methods to it. And after modeling the noise, you are able to reduce the error of the sensor readings. Okay, or you are able to calibrate the sensor. So this is regarding sensor fusion, sensor calibration, and noise modeling. Okay. So I to just jot down the terms. Okay, these are covered those in very brief. Okay, these are very important for mechatronics engineering. Okay, or mechatronics engineer or a engineer who wants to build robots and AI embedded hardware. For those particular person, this is very important. And if you have any doubts, then feel free to ask me. So in regression, just in plain regression, you assume expected value of error is equal to zero. So expected value of error, if it is zero in this particular case, expected value of error when expected value of y given x will be equal to x. Okay. So your first equation is derived from your second equation. Okay. First equation was this one, and second equation you have derived from first equation only. This is how I showed you. But they are not the same thing. When expected value of y given x will give you the average behavior. It will be theoretical, it will be noise free because you have not incorporated any error value epsilon or error value e. Okay, you have not incorporated any of those terms. Okay. But in case of y equal to x plus e, your actual observations will be there with the randomness. So there is a crucial difference. There exists a crucial difference between those two particular terms when it comes to statistical analysis. Hence, this particular statement will be taken as false. Okay. So this particular term will be false only. Okay. Now moving forward to the second question. Which of the following statements is correct? Sensitivity in ROC analysis is called true positive rate. Specificity in ROC analysis is not called true negative rate. Okay. Specificity specificity in ROC analysis is called true positive rate. Or sensitivity in ROC analysis is called true negative rate. Okay. This you try to tell me. Try to solve. Try to give your opinions. Okay. One. Okay, good. One. Okay, good. One. Okay, good. Rest of the people try to give your opinions. What about others? Try to give your opinions. One. Okay, good. Sensitivity equal to 2 positive rate by the specificity equal to 2 negative rate. So this statement will be true. One. Okay. Great. Let us see. The correct option would be one only. Okay. So all of you whomsoever have answered, I think all the students have answered it correctly. It is one only. Okay. Good. Let us see the terms in detail. Okay. In your classification matrix or ROC analysis, sensitivity will be equal to true positive rate. What is true positive rate? That is true positive over true positive plus false negative. Okay. It will measure how well your model actually identifies the positives. This is exactly what the ROC curves plot on the y-axis. Specificity will be equal to true negative rate. True negative rate will be true negative divided by true negative plus false positive. It will tell how the model will identify actual negatives. Yeah. So sensitivity is called true positive rate. This statement is correct. Specificity is not called true negative rate. This is incorrect. It is only called as true negative rate. Specificity is called true positive rate. This statement is incorrect. Okay. Sensitivity is called true negative rate. No, it is also incorrect. Only statement one is correct. Okay. In case of your confusion matrix, okay, in case of your confusion matrix, this one is the confusion matrix structure. It is having positive, predicted negative, actual positive, actual negative. Okay. Here positive and negative, supposedly you can take is an example of two classes. You can also say like this, class 1, actual predicted class 1, class 2, okay. Then actual class 1, okay. And actual class 2. Okay. You can say like this. So true positive, then true positive is when it is actually positive and it is predicted positive. So it will be true positive. It is predicted negative when it will be when it is actually positive, but the model has given it negative. Then in that particular case, it is false negative. When it is actually negative and the model has predicted it as positive, then it would be false positive. Always go for what is the prediction, what the model has done. When it is negative and it belongs to negative class, it will be true negative. Okay. So specific, for example, sensitivity is a term. Sensitivity will be your true positive variable. Okay, TPR. That will be true positive rate. This one divided by true positive plus false negative. True positive plus false negative. This particular one. That will be your sensitivity. So it will tell us how well the model has detected the actual positives. Out of all the real positives, how many did we correctly identify? Okay. Now you try to see the term specificity. Specificity will be your true negative rate, TNR. It will be true negative divided by true negative plus false positive. True negative is this particular term. Okay. True negative divided by true negative plus false positive. Okay. This term. That will give you specificity. It will try to measure how well the model detects the actual negatives. Okay. Out of all the real negatives, how many did we correctly identify? Yeah. That will be your true negative rate in an arm. For example, in case of a medical test, okay, total number of patients is 100. 40 actually have the disease. 60 do not actually have the disease, then it is negative. Okay. They are having disease, it is taken as positive. And suppose a particular matrix has been provided to you such that 30 are true positive, okay, 10 are false negative, 15 are false positive, 45 are true negative. For example, this is a particular matrix or conclusion matrix that has been given to you. Now you try to calculate various matrices. For example, sensitivity, if you want to calculate, how you will calculate? It will be 30 divided by 30 plus 10. Okay. Sensitivity from a confusion matrix. How will you calculate? You will identify what is true positive. True positive it is 30. 30 divided by 30, this term plus this term. 30 plus what 10. Okay. So it will be 3 by 4. 3 by 4, how much it is? 0.75. Now you try to calculate specificity. There is one term sensitivity, another one is specificity. Specificity, if you will try to calculate, it will be true negative. True negative is how much? 45. And 15 plus 45. That is false positive plus true negative. So how much it will be? It will be 45 divided by 60. That will also be equivalent to 3 by 4. 15 threes are and 15 fours are. So 3 by 4 is 0.7. Okay. So from here, I will get sensitivity as 0.75, specificity as 0.7. Both the values will be equal to 0.75. What is the interpretation? If a model is having high sensitivity, it means it is having few missed positives. Okay. If a model is having high specificity, if it is model is having high sensitivity, it will be having less or few missed positives. Okay. If it is having high specificity, it is having few false alarms. Okay. So important when treatment is risky. Okay. So ROC connection, ROC curve plots will be on x-axis. Okay. You will be having FPR, false positivity rate, that is 1 minus specificity. And in y-axis, you will be having true positive rate. It is sensitive. Okay. In case of your ROC, in x-axis, I will be having 1 minus specificity. 1 minus specificity. And on y-axis, I will be having this sensitivity. Final takeaway, TPR focuses on true positives, TNR focuses on negatives. This measures two different types of correctness. Okay. It is very important in case of your classification models to understand the exact evaluation, exact process, how crucial the model's correctness is. Okay. It is very, very important. Yes, this is again written in this particular terms. Okay, these particular terms are written in summary here. Okay, core idea is to actual to condition as well as comparing with the model output. True positive is there, to be negative is there. False positive is also known as type 1 error. Okay. And false negative is also known as type 2 error. False negative is also known as type 2 error. Sample table already I have explained. Sensitivity, specificity, and accuracy, as well as real life analogy with the medical diagnosis classification or spam classification you can know. Okay. Next, we come to the another question in ROC analysis when the threshold value is higher. Specificity decreases, sensitivity decreases, both A and B or none of them. Try to solve. B. Sensitivity decreases. Okay. Let others how to solve. B. Okay. B. Good. Using threshold makes the model stricter, so fewer positives are detected, reducing the sensitivity. And so option is B. Okay. B and A. Okay. Good. B, 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 A, and B. Okay. Good. Do you know when was this concept of ROC, receiver operating characteristics, first came into being? This came into being in first time, for the very first time, it was used in World War II. So now we are at the brink of World War III. So that is why I am telling you like where it all started. These all the things came into being in case of the World War II. If you see engineering in itself, okay, the very first form of engineering was defense engineering only. Okay, so it all started from World Wars, World War One, World War Two. So nations used to pour money only in case of your defense engineering. Okay, making defensive equipments, guns, missiles, tanks, bombs. Okay, so from there, there was you must have seen the radar sensor. Okay, so radar scans for the various objects which are there in the sky or which are at the ground level, or nowadays the technology had advanced to LiDAR, light detection and ranging. Okay, so in that particular sensor, it can be sought to be said to be a sensor. Okay, so in that particular sensor, okay, there it used to sweep in 360 360 degrees. Okay, so it used to cover the entire directions, and in entire direction, what are the total number of objects it will see? It will how it will tell by radar cross section area. So how to calculate radar cross section area fastly? Okay. So from that, uh, in order to calculate that, Simpson's rule came first into use. Okay. How to calculate the area under the curve? Okay. In a very fast manner. So different objects which were there in the sky, they used to have different radar signature. Radar signature is the term, okay, which is generally used for the cross section, which that particular object will make on the curve that is plotted by the radar. Okay. So radar will be emitting the radio waves it would be sending radio waves and it would be receiving the reflection of the radio waves, okay, from the certain object. Okay, this is how radar works. So whatever is the amount of waves which is it is receiving back, it will try to measure and it will try to plot on a 2D or 3D map. Okay. What 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 exactly is the cross section? Uh, it has related the amount of waves which is it is receiving. The radar sensor is receiving, okay, from the particular object after reflection. How much is the actual wave intensity it is receiving? So it is plotting it onto a 2D or 3D map. Okay. So the particular cross section of that particular of the object, okay, that cross section has to be calculated very fastly in order to identify whether it is an enemy aircraft or our own aircraft or it is a bird. It is what type of object which is there in the sky. So for that particular purpose, Simpson's rule for various other algorithms are there. They are used to calculate the exact area under the curve very fastly. So that came into picture. And from there only, this particular thing, ROC, receiver operating characteristics, they come into picture. It will try to give you idea about the classification. So classification of objects came first from World War II. Entire foundation is of our engineering is wars only, because whenever it comes to our safety, we apply to core, we tend to core resources, man, human power, engineering, and each and everything. The countries they spend billions of dollars in R&D in defense sector. Okay. So the technology it originates from there itself. Okay. That is the correct. So in ROC analysis, when the threshold value is higher, what is the thing which happens? Only option B is correct. Sensitivity decreases. Sensitivity decreases. Only this happens. This one is not correct. Specificity does not decrease. Only one would be correct. Both cannot decrease or increase simultaneously. One will increase, then another will decrease. That will be there. In case of your ROC analysis, the threshold determines how strict your model is in labeling something as positive. Okay. Higher is the threshold, model will become more conservative. It will try to predict positive only when probability is very high. What happens when threshold increases? There will be fewer positive predictions. Okay. Some cases that were previously identified as positive will now be treated as negative. What is the impact of sensitivity or true positive rate? Sensitivity is true positive rate divided by true positive plus false negative. So true positive decreases, false negative increases. So sensitivity in itself will be decreasing. Okay. What is the impact of specificity? Specificity. So sensitivity, it will be decreasing because true positive decreases, false negative increases. Okay. Specificity will be true negative divided by true negative plus false positive. False positive is decreasing. So true negative will increase. Okay. Specificity increases, not decreases. So specificity decreases? No, it does not decrease, it increases. Specificity increases. Sensitivity decreases. Yes, it is correct. Sensitivity decreases. Both can be. None cannot be the truth. Higher value of threshold, stricter is the model. Few false positive, higher is the specificity. And with more positives, lower would be the sensitivity. So sensitivity decreases is the correct answer. Is the correct answer. Okay. Very good. Try to solve this particular question. Sensitivity in ROC analysis is defined as true positive, where true positive is CP, false positive is FP, true negative is true negative, false negative is false negative. Try to give the exact answer. By now, since I have explained in much detail, everyone should try to solve this particular question correctly. Okay, try to give the correct answer. You all should be able to handle this particular question correctly. Okay, do try to solve. Okay, I'm just coming in few minutes. Yes, D indeed. Okay. D indeed. Almost all have solved it correctly. D indeed will be correct. Okay. By now, I think if you have heard it, my talk from past 1 hour, you should be in a position to tell that sensitivity is true positive divided by true positive plus false negative. Okay. Rest, first option was false positive plus true negative. That is false positive. Okay. That one is incorrect. False negative divided by true positive plus false negative. That is also incorrect, which is 1 minus sensitivity, also known as misread. C is specificity. True negative divided by true negative plus false positive is specificity. Okay, that one is also not sensitivity. Okay, sensitivity is this one. That is true positive divided by true positive plus false negative. Okay, that is sensitivity. Sensitivity focuses on actual positive cases. Okay, it focuses on actual positive cases. It evaluates how many are correctly captured. Okay, option number D is 100% correct. Okay. In case of your ROC analysis, okay, receiver operating characteristic analysis, okay, ROC analysis, a classifier is called good. Okay, if it has low TPR, low FPR, low TPR, high FPR, high TPR, low FPR, high TPR and high FPR. You must be knowing TPR and FPR, true positive rate and false positive rate. Okay. So try to tell your opinion about this particular question. In case of ROC analysis, a classifier is called good if it has low TPR, low FPR, low TPR, high FPR, high TPR, low FPR, and high TPR and high FPR. D. Okay, good. C and D. Okay, two opinions have come. C and D. D and C. Okay. There is some discrete difference between C and D. One term is high, both one term is high, one term is low and another term is low and high. C. Okay. Most are saying C. Good. D also, C also. Good. Indeed, if you will see, the correct option will be C only. Okay, high TPR and low FPR. Okay. In case of your ROC analysis, okay, TPR already told you true positive rate, sensitivity. False negative rate, FPR. FPR will be false positive rate divided by false positive rate plus 2 negative. What is a good classifier? A good classifier should correctly detect the positives. That is, it should have high TPR. It should avoid false alarms. It should have low FPR. Okay. High TPR and low FPR will make a good classifier. Okay, good classifier. ROC curve inside the ideal point on ROC curve is TPR equal to 1 and FPR equal to 0. Okay. TPR equal to 1, FPR equal to 0 will give you maximum ideation. Okay. Or the most correct model. Okay. It corresponds to top left corner of the ROC curve. Okay. Evaluating other options, low TPR, low FPR, no, low TPR, high FPR, high TPR, and low FPR. It is best trade-off. High TPR and high FPR, okay, it is too many false negatives. So finally, a classifier is considered good when it will be detecting most real positives. Okay. It will be minimizing your incorrect positive predictions. Okay. So high TPR and low FPR. Okay. High TPR and low FPR is correct. Okay. That is okay. High TPR and low FPR. Okay. High TPR and low FPR. High TPR, low FPR. Okay. That would be your characteristic of a good classifier. Now we try to compute for the given confusion matrix recall value. Okay, recall and one score. Okay, both of these values you try to compute. But first compute recall. Okay, recall what value you are getting for this particular confusion matrix. Where true positive, true negative, predicted positive, predicted negative have been given. 8327. Okay. See, good. So it means 0.78 you are getting. Okay, which method is also calculated? C. Okay. C. Good. D. Okay. Good. Answers. D. 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 Okay. Good. There is a conflict of opinions between C and D. Okay. Good. We will see whether it is C or D. The rest of the students also should try to give opinions. Indeed, if you will see, it will be D. Okay, it won't be C. Most of you were saying C, then you translate it to B, no problem. We do D only. Okay. See here, you decode the entire confusion matrix like this. This one term will be true positive, false negative, true negative. Recall is sensitivity only. It is true positive divided by true positive plus false negative. Okay. So it will be 8 divided by 8 plus 2. 8 divided by 8 plus 2 is 8 over 10. 8 over 10 is 0.8. Final answer is 0.8. So what is the meaning? What is the meaning of recall as 80%? 80% of actual positives it has identified correctly. 80% of the actual positive cases it has identified correctly. Okay. So it is having a good sensitivity. That is the meaning. And it would be 80%, 0.8. It would not be your 0.78, it would be 0.8. Now, next question, state true or false. Precision is inversely proportional to recall. Okay, that is the question. Precision is inversely proportional to recall. Try to give your opinions whether it will be positive, it will be true or not. True. Okay, good. Good. Precision is inversely proportional to recall. Yes. We will see. Yes. Okay. Good. True, then false. Okay. Good. The rest of the people also try to give your opinions. this particular statement is false. Okay, it is not true, it is false. Why so? Because precision, if you will see, it will be true positive divided by true positive plus false positive. Okay, and recall will be equal to true positive divided by true positive plus false negative. So precision tells us out of the predicted positives, how many are actually correct. Recall tells us out of the actual positives, how many did we correctly detect. Okay. So if you will see, are they inversely proportional? If you will try to see, I don't think so. Not exactly they are strictly or exactly they are inversely proportional. Precision will try to be dependent on false positives. This particular term. Recall will be dependent on false negative. This particular term. Okay, false negative. So they are influenced by different types of errors, type 1 error and type 2 error. So there is actually a trade-off between precision and recall. That is precision recall trade-off. Okay. When you are changing the threshold value, increasing the recall may decrease precision, increasing the precision may decrease recall, but strictly it is not like 1 upon x. Y is inversely proportional to 1 over x, that strict dependency is not there. Okay. So they can move in opposite directions in practical experiences when you will be training the model. They there is a possibility that might happen, but not exactly. Okay, it shall not be a possibility. So inherently they might not be inversely proportional. So statement is that is the that is the thing. Okay, it may not be inversely proportional. It may not, this relationship might not strictly hold. That is the thing. Now try to solve this particular question. State true or false. Standardization of features is not required before training a logistic regression model. What you will say about this particular statement? Whether it is true or false. B. False. Okay, good. Okay, B. Good. Okay, good. See here, correct option would be A only. Okay. Standardization of features is not required before training a logistic regression model. This particular statement is true only. Okay, this particular statement is true only. Why so? We will see. Logistic regression does not strictly require the feature standardization. Logistic regression is not distance based. Okay, unlike the k nearest neighbor or support vector method or the RBF kernel. Okay, in neural network, radial basis function is there. Radial basis function kernel. In those particular functions, okay, or methods, the standardization, feature standardization is a necessary step there, but not here. It will use the model probabilities, okay, using a linear combination of features. So in theory, it can work with different features on different scales, but practical note is there that theoretically it is not required, but it is often recommended, or we often tended to use it because it improves the numerical stability. It helps the gradient descent convert faster. It will ensure the regularization, L1 and L2 regularization. They will work properly. It will prevent feature with large scales from dominating. Okay. So statement says not required. It is correct. But in practice, it is usually beneficial. Okay. So this statement is okay, this statement is now we try to see this particular question. Which of the following option is true? Which of the following option is true? Linear regression errors values have to be normally distributed, but in case of logistic regression, it is not the case. Logistic regression errors values have to be normally distributed, but in case of linear regression, it is not the case. Both linear regression and logistic regression error values have to be normally distributed. Both linear regression and logistic regression error values have not to be normally distributed. Out of these two forward statements, which option will you choose? A. Okay, good. C. Okay, good. A. Okay. Now we try to see here the correct option would be A only. Okay, linear regression error values have to be normally distributed, but in case of logistic error, it is not the case. Many a times In our previous sessions, we have discussed this particular statement and in itself is correct. Okay. In case of your linear regression, the error term or the residuals, okay, I have drawn a figure and showed you how residuals are. What residuals are, I remember it correctly. Okay, the residuals, they will follow a normal distribution, okay, with a mean that is zero and standard deviation that is sigma square. Okay, where is square? Okay, so this is assumption is important for hypothesis testing. Okay, and confidence intervals. Okay, the model itself is y equal to beta 0 plus beta 1 x plus e. In case of your logistic regression, it will not assume normality of errors. Okay, so it will assume that the response follows a Bernoulli or binomial distribution. It may follow, it may not follow. Okay, it does not assumes the normality of errors. So it uses a logistic sigmoid function, okay, that is p when y is equal to 1 over x, 1 given x, that is 1 upon 1 plus e to the power minus z. Okay, uses a logistic or sigmoid function. Sigmoid function is this particular one, 1 over 1 plus e to the power minus z. Okay. Errors are not normally distributed because output is categorical in this particular case. Categorical classification means binary, 0 and 1. Model is based on maximum likelihood, okay, not on least squares. Okay. So yes, A is correct. Okay, B is not correct. That is the opposite of statement A. Okay, B is not correct. C is also not correct. Logistic error, logistic regression does not assume normal errors. No. Okay, this statement is partially correct. Okay, both linear regression. No, 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 no. This particular statement will be 100% correct. Both is written here, so no, no, it is not the case. And B statement was both linear regression and logistic regression error values have not to be normally distributed. No, this is also not correct. Okay. Logistic regression errors values have to be normally distributed. No, 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 no. This is also not the case. That is the one. So only option is correct. Okay. That is the one. Now you try to see this particular statement. Which of the following is true regarding the logistic function for any value x? Okay. Logistic of x is a logistic function of any number x. Logit of x is a logit function of any number x. Logit inverse IMV is an inverse logit function of any number x. Statement, these statements are there. Logistic x is logit of x. Logistic x is logit inverse x. Logit inverse x is logit inverse x. Okay. So none of the okay. So which of the following is true regarding the logistic function? Try to tell this particular question. What are the opinions? No opinions? Try to give your opinions. A. Okay. Good. B. Okay, good. Yes, the answer to this particular question would be B only. Okay. Why so? Logistic function, if you will try to see, that is also known as the sigmoid function. That is 1 upon 1 plus e to the power minus x. It maps any real number from minus infinity to plus infinity to 0 to 1. Used to convert linear output into probability. Yes, because the infinity, the any number from ranging from 1 minus infinity to plus infinity that has been confined to 0 to 1. Probability of any event will be uh, confined between 0 and 1. Okay. So yes, this is correct. Okay, regarding logistic function, logic function, if you will see, that is nothing but the natural law of P over 1 minus P, where P is the probability. It maps to probability. Okay, P is the probability and it's a real number. It lies between 0 to 1. It is the inverse of the logistic function. Okay, key relationship is logistic function. Okay, is inverse of the logic function. Okay. Means logistic function is inverse of the logistic function. Logistic function is inverse of the logic function, and logic and logistic are not the same, but they are the inverse. Okay. So logistic of x is equal to logic of logit x. It is not correct. Logic inverse x. Logit inverse x means in the inverse, ln inverse p over 1 minus 2. No, it is not equivalent to logit of x. Okay. Logistic of x is equal to, yes, this statement is true. Logistic x is logic inverse x. Okay, this statement is correct. Yeah. Finite insight is this, that option B is only correct. Okay. Because here only it has been correctly displayed. Logic is the transformation of probability from real line to the probability. Okay. So you try to remember logistic function is inverse of your logic function. Okay. Inverse of your logic function. Okay. Then you try to remember. Okay. As well as you can very easily prove it also. Okay. You have to prove it also whenever you if you are interested. Okay. Just uh, write down this logic of logistic write down the inverse of this particular function, inverse of this particular function, try to take it as y. So very easily you can prove y, take it as p over 1 minus p, then we take anti-log both the sides, e to the power y will be equal to p over 1 minus p. Then you try to solve e to the power y minus p e to the power y equal to p. Try to solve this particular equation and calculate the value of p. You will get what? P equal to 1 over 1 minus e to the power y. Okay. E to the power minus y. Okay. It will prove that logic, logistic function of x equal to logic inverse x. Try to just solve p from this particular equation. You will get the same statement. Okay. That is the thing. So this marks the end of the 10 questions which I wanted to discuss. Now I'll move forward with some of the coding examples. Okay. Try to go to Google, then go to Colab, then you go here, welcome to Google Colab. Then download this particular notebook. I'll share with you on the folder. Okay. Then go to upload and browse the URL or the location of the link where you have downloaded. Okay, this particular notebook. IENV notebook. Okay, you try to upload, try to run, play with various parameters, and try to develop your skills in coding. Okay. So importing libraries, first of all, importing NumPy is NP, matplotlib or pyplot is PLT, sklearn datasets, you have imported classification, regression, logistic regression, linear regression, then sklearn.matrix, I have imported confusion matrix, ROC curve, AUC, area under ROC curve, precision score, recall score. Then for reproducibility, I have imported np.randomc. Then for then I have generated classification data, random data I have generated. Then I have fitted a logistic regression model on X and Y to arrays which I have randomly generated. Then I have mapped the probabilities, then calculated made the threshold. I fixed the threshold. In the next cell, you will see I have made a slider for the threshold. Then I have plotted the confusion, I have made the confusion matrix. Confusion matrix as a function I have called. It will try to fit Y and Y predicted values. Okay. This particular array you have to see from the library how it is plotting the confusion matrix. The thing which you are manually doing, okay, for the confusion matrix table or for the fitted data, it is trying to do automatically, but you have to see the function, how it is functioning. Okay. And true negative, true positive, false positive, false negative, true positive, I have calculated from cm.raval. Okay. This is nothing of some function of confusion matrix. It will automatically calculate all the values and transfer to the variables. Then print confusion matrix cm. Okay, I have printed. The matrix precision, recall, specificity, I have calculated manually. Then ROC curve I have tried to plot. Okay. False positive rate with respect to the true positive rate. These values have plotted and calculated the ROC curve. Then threshold effect visualization. Just performed with the okay threshold to test np dot line space. Recall specificities I have declared as empty array. Then for all the observations, probabilistic by observations, calculated recall specificity, then appended to the recall and specificities arrays, okay, empty arrays. It is the thing. Plotted the array, okay, plotted the figure, okay. Threshold value, threshold and versus specificity and sensitivity, all the plots are formulated. Then logistic versus linear regression I have given. Okay. Try to make the comparison. Okay. Linear model as well as the linear regression model as well as the logistic curve visualization I have performed. Okay. So logistic sigmoid function you try to see, then X, then probability. Okay. That we have done. So NP dot line space. Okay. This particular statement I have fitted the logic and logistic regression relationships. Okay, inverse relationships I have tried to plot. I have told you that one function is inverse of the another. Okay. So confusion matrix for the random x and y arrays that has come like this. Okay. Matrix is threshold. Threshold value set it at 0.5. Precision set it. Okay. We call set specificity calculated. ROC curve. This I have got. True positive rate, false positive rate, okay, and ROC curve I have got. Area under the ROC curve, okay, actual area under the curve 0.93 I am getting. Threshold versus sensitivity and specificity. Threshold is like this. The value of sensitivity or the recall is like going like this. Specificity is increasing. Linear regression fit plot. Here I have just got like this linear regression plot. These are the data point. This is the fitted line. And logistic regression fitted plot, probability versus X. I have got like this. And logist and logit and logistic are the inverses. Okay. So when I have plotted the function, okay, I have got straight line curves. Okay, 45-degree line I have got. Okay, check inverse values. Are the values close? Yes, they are close. Okay, it is given true. Okay. Why, how it is given true? Because we are calculating. Okay, we are calculating in the tolerance which I have given as 10⁻⁻5. When both the values will be in this particular tolerance range, it will raise the flag as true. Otherwise, it will raise the flag as false. So this is the thing. Now in the next cell, that all the things I have given same. Just there is one upgrade. I am I am able to change the threshold value. Okay. Just one second. Not corrected the runtime. That is why threshold value is not changed. Since that data was generated random, so you will see every time I will run the cells, the values will change because it is np dot random seed. Okay, random function I have just used. That is why for all the every time you will run this notebook, values will change. Okay. So don't get surprised, sir. You are having different values. I am getting different values because it is a random function when data. Randomly it is generating x values, y values, and randomly it is trying to fit the regression points. Logistic regression and linear regression. So if you try to change the threshold values, okay, each and every values will change. Confusion matrix will change. Okay, it was something like that. Now if I will change the threshold 0.70, see, curves are changing. Confusion matrix stays like this. True positive, true negative, false negative, precision, recall, and then I am getting the update. So threshold, if you want to change with this slider, you can change. Both the curves will change. Okay, nature of the curves as well as fitting will change. This was regarding the 10 questions in the practical applications of these questions with the demonstration with the help of a Google Colab model. Okay, this is all for this particular session. Thank you everyone for joining the session. Please join the session next week, same time, same link. Now it is open to you. If you are having any doubts, feel free to ask. Best you can find me. Okay. Thank you once again for joining the session. Do join the session next week, same time, same link. If you are having any doubts, feel free to stay. Rest you can find me. Thank you. How we set the probabilities. You are talking about the Google Colab notebook or anything else? How you set the probabilities? This is the question which you asked. Okay, you are talking about this particular notebook. In this particular notebook, try to see here. The probabilities which I am getting, okay, they are not set. First of all, they are fitted. Okay, the model is fitted. Then actually, what is y prediction and what is the actual value of y? Okay, y will be an array, x will be an array. Okay, suppose it is like this, x is an array 1 and 2. Okay, y is an array 3 and 4. Okay, so the relationship will be fitted between y and x, and then your actual probabilities will be calculated. Okay, or actual probabilities will be calculated. Y probabilistic value of predicted. Okay, predicted y. See here, then it will actually predict. Okay, actually predict each and every value, and then it will try to calculate the probability. What is the exact probability where model will be calculating the exactly correct value or incorrect value. So for each and every value, I have calculated the probability. I haven't set it the probability. Model I have fitted. Okay. But the values for each and every predicted value of y and actual value of y that I have calculated. Where do you get the Google Colab notebook? Okay, great. Just 1 second. Where this particular Google Doc notebook is there, I will bring it. But I can print it. No, I cannot. It go away. Yeah. See, there is a link of Colab notebook. Okay. There is a Google Doc link which I have given to you. Okay. When you will click on this particular link, see here you will get this particular, these all the YouTube video recordings are there serially. Okay, till week 8. Week 9 is this one. Okay, after it is over, okay, I'll upload the recording, share the link there. Go to this particular presentation, Google Drive link. Okay, here week wise content is shared. Okay, so week 8, if you will see here, see IPYMB file is there. You just download it, then browse the link. Okay, here you will be able to execute the Google Colab model. As well as some of the students are using Visual Code Studio as well as some another IDE to run Python. For that, for them, I have given the ey.python file also, as well as the PDF is also there. Where you can download it, open it, okay, comment whatever you would like to do with it, you can do, but go through each and every content which I mentioned. Okay. Save this particular link, okay, for future and for your reference. Save this particular link. I don't know whether they are mailing you the link or not. They should send the email to each and every student. If it is not the case, then just copy this link and save it somewhere safe. Okay. Then you would be able to access the particular sessions are being held. So you would be able to receive the recordings of both the sessions. See both the TAs are placing their links. Okay. That is that one. Can you explain me what is the meaning of threshold? I'll explain you threshold. I maybe did it, but I will explain you threshold once again. No problem. Threshold, if you will try to see, okay, threshold, if you will try to see, it's a decision boundary or which is used to convert the continuous output which is coming from the model. Okay, which are typically like probabilities or the scores into your class levels, binary class levels. Okay. Model will be giving you probabilities, but you have to convert the continuous probabilities which are coming into from the models, okay, into scores. So how you will do it? With the help of threshold. Suppose I have set the threshold as 0.5. So if the model is confident about the probability which is coming from the model is 0.49 or it is 0.3. Okay. So model will be labeling that particular value into one class. Suppose class 0. And if the probability which is coming from the model is 0.5, 0.6, 0.51, 0.73, means it is greater than 0.5. So it will be going into some another class. Okay. So threshold is that particular limit or that particular value which is the deciding factor. That the continuous probability which is coming from the model, it will the model will put into which particular class, whether it will go to class A, class B, or class C. So the continuous probabilities which are coming from the model, fitted model, which I have fitted here. Okay. I have see here I have written the model equal to logistic regression model dot fit x and y. So model will be giving me the continuous probabilities, these probabilities, y probabilities. Okay. So I have to set a particular threshold, and that particular threshold is that particular value, which is deciding factor that the output from the model will go into which particular class. Class A, class B, class C, class D, any of the class. That is why I am giving the condition here. Why probability is greater than equal to threshold, then only you will set it into that particular class. Otherwise, it will not go. Okay, that is it. Understood? What any doubt is there? What happened? Understood? Not understood? Give response. You can unmute yourself also. If you are not clear, then tell me. I will repeat. If you are clear, then tell me yes, understood. Clear? Good. Okay. If no doubt, further doubts are there, then I shall end the call. Okay. Thank you all once again for joining the session. Okay. Please join the session next week, same time, same day. Thank you once again. Okay. Please join the session next week, same time, same day. Okay. Thank you. Yeah. Okay. Bye. Have a great day. Okay. Thank you.